Yeah, good evening, everyone. Welcome back to the live session of Getting Started with Competitive Programming. This session and this is last session for this term, and we will cover like last 3 week problems that graded programming assignment today. And if you have any query, you can join the session and you can also ask your query. Okay, so Sayan and Pulkit, can you start?
Yeah, so I'll start with week 10, problem 1. Let me share my screen. Yeah, so this is the first question of week 10. So in this question, you're basically a graduate student who has graduated from a tailoring degree, and then you have become a apprentice under a tailor. So as your first task, you have to find the beautiful pattern, the most beautiful pattern from a given roll of patterns. Right? So the way that you're like the person you're working under makes sure that the patterns are the most beautiful is they're using symmetrical, like vertically symmetrical letters. Right? So a pattern is beautiful if the pattern has a higher, like a pattern A is better than pattern B. If the length of pattern A, the function of length of pattern A is greater than function of length of pattern B. So what is the function? The function is simply a polynomial plus an exponential function. So it's 15 plus x square plus x cubed all the way till x to the power 51. And then we add a e to the x. Right? So this function may look a bit daunting at first, but you can soon realize that this is a monotonically increasing function. So as the uh, gradient of this function is always positive, so this will always be increasing. And thus, if you want to maximize this function, you can just maximize the value itself. So if you maximize x, you will have a maximal f of x. So the argmax of x and argmax of f of x are both the same thing. So in this case, the best pattern is simply the pattern that has the longest length, or the one that is the longest. So now the problem boils down to finding the longest pattern in the roll, which is symmetrical. So this basically means that we have to find the longest palindrome in the string. So finally, once you have found out the longest palindrome, you have to see if there is no issue of money, but you have to see if it can be done within X minutes. So that can be done if each pattern takes p approximately p seconds. So the entire thing will take p times s minutes. So the total, so s is the unit time and p is the length. So p times s is the total time it will take to create that pattern. And you have to do it in less than or equal to x minutes. You have to find out whether that can be created before the event showdown or not. So let's see the input format real quick. So as always, we have the number of test cases first. So we'll test on multiple test cases in each iteration. And then the first line of each test case contains 3 space separated integers n, x, and s, which are the length of the pattern roll, the time left to create the design, and the time required for a pattern of length 1 to be created. The next the next line contains a string of pattern of length n. So let us see the constraint for this problem. So there can be at max 10 to the 3 test cases, and the effort will be at max 10 to the 3 length of the string. And x and s, which are the times, can be at max 10 to the 8. So 10 to the 8 itself might seem to fit in an integer, but if you multiply this with the length, then this can overflow. So thus we should actually store these in a long. And finally, each letters of the pattern strictly follows only these letters, a set of these letters, because these are letters in English alphabet that are vertically symmetric. So they look the same if you see them through a mirror or not. You can see why that is the case if you go through the problem statement in detail. So that is what you are trying to accomplish. And the output should simply be a 1 or 0, denoting whether you can create the pattern or not. So this is an example. We have one test case. We have a pattern of length 10, and we have 10 seconds, and each pattern takes 1 second. So here you can see the longest substring we have is this. So HAIMIAH, and this is 7 letters long. So if each letter takes 1, so 7 times 1 is 7. So you'll need 7 minutes to make this pattern, which is less than a total of 10 minutes that you have. and thus the answer is 1. If let's say the total time you have was 5 minutes, then the answer would have been 0. Now, the solution for this question is pretty simple. So first we go through the proof that you don't actually need to evaluate the function. So if anyone is still not sure, I'll leave the proof up for you. We won't be going through it like step by step, but this basically uses the fact that f of x is monotonically increasing for all x greater than 1. And due to that, we can simply maximize x instead of f of x. So you can find the derivative and find out that it is always positive. Right. So thus a greater than b is a biconditional implication on f of a greater than f of b. So we simply find the string with the longest length. So the solution for this is pretty simple. So we have to find the longest palindrome. So to do this, so a palindrome can either be of even length or odd length. So let me quickly draw up a few examples. So if let's say the example is the word race car. So here you can see the first and last match, second match, third match, and the fourth one, it's basically matching with itself, right? So if we have odd lengths, then we want all the pairs to match up, but the middle one will pair with itself, right? So you don't need to have another letter here. It can just always satisfy the condition that the letter matches with itself. However, if we have a palindrome of 4 letters, so let's say A, B, B, A, which is name of a band. So here you can see the first and last match and the second and third match. So here you don't have a middle element. So all of these will have to have a discrete match. Right? So we have the two cases for odd and for even. Right? So the result is basically the longest palindrome that we initiate as an empty string, and the length of it is initiated as 0. And then we go through all the possible lengths that is possible. So it's for I in range, length of the string. So the biggest palindrome possible is the entire string itself. So we go from all the way from 0 length to the length of the entire string, -1. And we basically take 2 pointers approach in this. So this is one of the classic ways of solving DP. So we take 2 pointers left and right, and we start at the index itself. So, and we have this condition where the left is in bounds, so it should not be negative, and the right is also in bounds, so it should not be more than the length. And as long as they are equal, right? So as long as the characters are equal in each step, we can keep on increasing the palindrome, or we can keep on building the palindrome. So as long as the r minus l plus 1, which is the length of the current string we are evaluating, it is greater than the uh, best we have till now, we can basically update. So it's same like a finding maximum logic. So if the current max is greater than our max, then we set the result length to be r minus l plus 1, and result, which is the string, to simply be that substring. So it starts from l and goes till r. So we're giving r plus 1 because the last index is included in string slicing in Python. And then finally, we expand the string in both directions. Right? So we set L to be -1 and R to be +1. So it basically means, so we consider each position as the middle point of the string. So let's say we take this same example that was given to us in the input. So the input was this one. So I'll copy this. So or let's just work here itself. So if this is the input that we have, we can consider each of the letters as the middle of the palindrome. We can start with X, then we go to H. But you will see as we go to M, this is the actual middle of the longest palindrome. So from here, we can keep on expanding. First, we can consider just M, which is a palindrome. Then we can consider one letter to its left and one to its right. So IMI, that is also a palindrome. And we can keep on increasing. We can do this, and it is still going to be a palindrome. And then we can again increase, and it is still a palindrome. Now, if we increase again, we can still increase, we are in bounds, but now this X and this Y do not match. So that is when the third condition in the loop will be true, will be false. So here the string of L will not be equal to string of R, and the while loop will stop iterating. Okay? So we find the odd length palindrome from that center, and we'll also find the even length palindrome from that center, because in this case, the parity of the length of the string itself does not matter. Rather, we need, so even if the string is odd length or if the string is even length, the palindrome present inside can either be odd or even length. So we have to always check for both the cases. Right. So in this, 1 second. So similarly, just like we saw for odd length, we will also see for even length. Right. So in odd, we start both left and right as at the middle element, but in even, we'll basically start left at I and R at I plus 1. Because in even, each element will have its like pair. So we do the exact same check here also. And in the end, we return the rest. So in each index, we basically consider that to be the center of the palindrome, and we keep on expanding as much as possible. So as you can see, that feels like an O of n square, but in each index, you will obviously not expand till the end. If that is the case, then so first of all, it will only happen in the middle element where we have a symmetric distance both to the left and right. And if that is the case, then we have already found our largest palindrome because nothing can be bigger than the string itself. So it will always be like at max n into n by 2. But if we add for the middle element, but if we add for all the elements, this will be not as big as n square. So, and then finally, we have the driver code where we are simply taking the input, a number of test cases, and for each test case, we take the n, x, and s, and finally the string. And finally, we just see if the best pattern of A, the length of that, the int of that, so the length itself should be in. So the number, which is the length of that pattern, the best pattern, times the S, which is the time taken for each pattern, if that is less than or equal to X or no. Yeah, sorry. So this int is actually converting this Boolean into a number. So if it's false, it will be 0. And if it's true, it will be a 1. So basically, it's checking if this is true, then print 1, else print 0. So that is how you solve this question in Python. Similarly, in C++, the logic remains exactly the same. We might have to do a few things explicitly, but other than that, the process is exactly the same. So we find out for two different things, odd and even length palindrome. And finally, if the length of that times s is lesser than or equal to x, then we print 1. Otherwise, we print 0. So make sure to store this as long in C, C++, or Java. So that is the solution for the week 10 problem 1. If you have any doubts, we'll discuss those. Otherwise, we'll move to the second problem. Okay, Pulkit, you can take over for the second problem.
Yeah. Okay. So let's start with the second problem now. So this is week 10 programming assignment question 2. Now the question asked is, we have given one popularity array and we have to basically sign K-pop idol such that if their popularity on some ith day, the elements in the popularity array is representing the popularity of new idol on the ith day. And we have to find a new idol in such a way that when they are on their lowest popularity, we have to find them, and then we can debut them when their popularity is at peak. So one thing is that we can only sign a new idol before debuting it. So the way we can do this is, let's say this is a given popularity array 7, 1, 5, 3, 6, and 4. So this 7 represents the popularity on first day, then 1 on the second day, and that's how the popularity is given to us. So the way we can sign this idol is we can sign the idol on the second day, because at that time the popularity of this idol is at the lowest. And then after that we can debut it on this day when its popularity is at 6, because this is the time when its popularity is at its peak. For the second test case, if we see, the popularity is decreasing on each day. So there's no way in which we can sign it such that on the next day, if we make this idle debut, then its popularity will be at its peak. So if we look at the solution code for this, we will create one function maxFem, in which we will take the input as the popularity array. Then we will define these two variables, that is the current fame of the idol and we are initializing it with the initial element value of the popularity array and the max fem value that we are initializing it with the variable 0. Then we are looping through this popularity array from 1 till the length of the array, and if the current popularity array value is less than the current fem, that means its popularity at that ith element is less than the current fem value, then we will sign it on that time. So we'll replace this current fem value with the popularity array of that ith element value. If it is not, then we are checking whether the popularity of on that day minus the current fem value, if it is greater than the maximum fem value that it can achieve. So if it is greater than, then we are replacing the max fem value with the popularity array of ith element value minus the current fem value it can have. And in that way, we will achieve the maximum fem value. And in the end, we will return this maximum fem value. So here we are taking the input, the number of test case, and then we are looping through the number of inputs. Then we are taking the length of the popularity array, and then we are taking the input dot split. This will create a list of inputs, and then using map function, we will map each of the element to the integer and create a list of that. And then we will pass this list to the max fem function to the result, and finally we will print the result. For the other language, the only thing that we need to care about is use of long, as a constant given to us goes till 10 power 10. So we can use the long here to do and store the current fem value and max fem value. The other things and the other logic remains the same, that we are looping through it and checking whether the popularity on the ith day is less than the current fem value. If it is, then we are replacing it. And if it is not, then we are checking the max fem value and reinitializing it. Same for the Java also, that we have to use the long here. And that's it. So anybody has any doubt? Okay, then you can do the next one.
All right, so let's move on to week 11, problem 1. Okay. So this is the okay. So this is it's mostly invisible. I think it is not. 1 second. Let me share that again. This is the week 11 programming assignment 1. So this is again a DP question. So in this question, you're basically playing a hybrid tabletop game. So hybrid tabletop game is basically a game where you take multiple tabletop games and you combine them. So this is usually done to make the game more exciting or fun, or to explore different strategies. So in this, you're playing a hybrid tabletop game, which combines the games of Jenga and Scrabble. So you can also look through the links if you're not actually familiar with them. So in short, Jenga is a tower stacking problem where you have to keep on stacking the bricks on top of each other, and you can pull the bricks out to get a new brick. And as soon as you cause the tower to topple, you lose and the other person wins. And in Scrabble, you basically have letters and you arrange them vertically, horizontally, or diagonally, and so you get each get turns to create words, and the word should be a valid word. And after the game ends, the person who has the most points wins. So the way the points are calculated is that each letter has a point assigned to it, and each word that you create is worth a point, which is the sum of the points of the individual letters. So in this game, you basically have to form words with the highest points to win, just like Scrabble. However, the tiles are placed in a tower like Jenga. So whenever you need a new word, sorry, a new letter, you have to take it out from the tower. And if you knock the tower off, the game basically ends. Right? So if you drop any tile, you immediately lose the game. So you will lose as soon as the tower falls. And after losing a few rounds, you realize that the tower won't fall as long as you do not pull out 2 consecutive blocks. So as long as you, let's say there are 5 blocks, if you pull out 1, 3, and 5, you're totally fine. If you pull out 2 and 4, that's also fine. But if you pull out, let's say, 2 consecutive things like 2 and 3, the tower will fall. So given the list of letters and their associated points in the game of Scrabble, so you have to find out the maximum points you can score as a percentage of the total available points. So what this means is you are given the list of the letters in the arrangement that they are present, and you have to find out the perfect combination of letters to take out from it so that none of the letters are consecutive and their total sum is the maximum possible. So you have to maximize the sum of the letters under the constraint that no 2 letters are consecutive. So it's a constraint optimization problem. So in this, the first input is the number of test cases. And then for each line, the test case contain a single integer n, which indicates the number of Jenga blocks. And the second line contains n space separated integers, which is the points of that block. And so the constraints are as follows. There are at max 100 test cases, and in each test case, there are at max 10,000 blocks, and each block's weight can be at max 10 to the 8. So individual weights fit in int, but again, if you have to find the sum of weights, they can sometimes overflow. So we can store them in long instead. So this is an example. We have one test case where we have 4 blocks, 1, 2, 3, and 1. So here, as we said, if we have 4 blocks, we can either take the first and the third, or we can take the second and the fourth. We can obviously also take just 1 block, but that does not make much sense because all of them are positive. So here, if we take second and fourth, we get 2 plus 1, which is 3. But if we take first and third, we get 1 plus 3, which is 4. So in this case, the maximum you can get is 4. And that is 4 out of 7. So your output would be 4 by 7 as percentage, which is 57.14. So this is the explanation of what we just discussed. So now let's see the solution for this. So the solution is pretty simple. So you have to simply find out the optimal between taking the current or not taking the current. So you basically have the weights array, which is the array that we are given, and you initialize A and B as 0. And for each weight, so for weight in weights, you take the max between the weight plus A or just B. So A is basically if you take this current one, and B if you don't. And finally, you set A is to A to B and B to B temp. So this is very similar to how you calculate Fibonacci, but instead of doing temp equals A plus B, you actually make it max of weight plus A comma B. So here basically you ensure that you find out the max of taking the elements where you never take 2 consecutive elements because they are stored in 2 different things. So as you can see, each time A and B are getting cycled. So A gets to be B and B gets to be the temp. So you always store the value of adding A to something as B. So next time you don't add it to A. And this gets cycled each iteration. And the driver code is also pretty self-explanatory. So you take the input and you iterate over the inputs and you simply take the N and the weights array. So finally, you have to find the blocks for the weights that we just found out. And the max points is nothing but the sum of the weights. So this is the total points, maximum points that you can get. And whereas this is the total points, which is just the sum of all of them. And the percentage is nothing but points by max points into 100. And you have to always print them in 2 decimal precision. So this is how you do that in Python. So this is a very simple question. So the C++ solutions are also exactly the same. So here you use vector instead of the list. And the weights itself can be integer. However, the max points and A and B, which are summing over these weights, should be long because they can overflow. Right? And similarly in C or C++, you can use again 0.2f and then this percentage for printing an actual percentage sign. So this similarly in C and finally in Java. So this is how we solve the week 11 problem 1. Is there any doubts with this? Then we can move on to the second question of this week.
Okay, so let's start with the second question now. So in the second question, they're asking is Kangteo is a mathematician who is developing a linear regression model to predict the balance of the energy stone. And these stones are yin yang stone, which carries powerful energy, and their proper arrangement is crucial for maintaining harmony in the kingdom. So a brief about that it models the relationship between a dependent variable y and one or more independent variables, which we can call it as like x1, x2 till xn if we have an independent variable. So using a linear equation, and the general form of a linear regression model is y equal to beta naught plus beta 1 times x1 till beta n times x plus n. So y is the dependent variable and the value which we are trying to predict here, which is also called as the target variable or the ground truth. Xi's are the independent variable is the predictor which helps us to predict the value of y. Beta naught is the intercept of the line. So how far it is from the origin, you can kind of effect like that. And beta i's are the coefficient or basically the slope corresponds to each independent variable. So like that tan theta of the line which is passing through the x-axis. And epsilon here represents the error term, basically the difference between the observed and the predicted values, because it is always not necessary that the independent variable and the dependent variable have a perfect linear relationship. So eta I is the variation of that. Am I not? Okay. So after training the model, Kangteo needs to analyze importance of each feature by looking at the absolute values of the coefficient. So the higher the value of a coefficient, the higher that independent feature corresponds to the highest prediction power. But by mistake, he overrode the original area of the coefficient that he derived by regression model values. Now challenge. So the challenge is he must determine the correct sign configuration, whether it is plus or minus for each coefficient, so that the total energy aligns with the second harmony threshold, basically the predicted values. And there can be multiple ways to achieve the same balance. So he wants to count how many valid configuration exist. And our task is to help Kangteo in this task. So we are given with the array coefficient where each value represents the absolute values of the coefficient. So as he is training the model with y equal to beta 1 x1 plus beta 2 x2 like that. So we are given the absolute values of beta 1, beta 2 like that. And we have to assign each plus sign or negative sign. And our goal is to count how many different sign configuration assignment result in a total sum equal to the target or the harmony threshold. The input format given to us is we have 3 test case, and for each test case the input is of 3 lines. First line contains the integer target which we want to predict. The second line contains the positive integer n, which denotes the number of the energy stone or basically the length of the coefficient area or how many coefficients are there. Then the third line contains n space separated positive integers where each integer represents the absolute values of a stone's coefficient. So the coefficient of the linear regression model. And we have to output is the number of valid sign configuration result in the total sum of target. So for example, for this array of 1, 1, 1, 1, 1 of length 5, value that we have to predict is 3. So the way we can do this is we can set the first one to minus. Then for all of them, we can set the sign as plus 1. So now these will result in 4, 4 minus 1, 3. Total output will be 3. And this sign arrangement we can do for all the other coefficient also. So basically like this. That first we assign minus 1 to the first coefficient, then to the next. And in that way, we'll get 5 different type of combination in which we can get the resultant value to be 3. For the second test case, where there's only one coefficient in the coefficient array, there's only one way to achieve to get the sum of target value here to be 1. So there's only one possible way to achieve this target score of 1. Now, before going to the code implementation, few things that we can get from here is, let's say P here denotes the sum of coefficient which results, which has positive sign. So some coefficient that we will take from the set in coefficient array, the sum of those coefficients for which we will assign the plus sign, let's say we denote them using P, and then for S we will be doing is the negative of this. So denotes the sum of coefficient which has negative sign. Equation that we can make it from here, that P plus S that we would want would be our target. So when you add the sorry, not add, here I should have subtract, because S is the sum of through which we are assigning the negative sign. So this is the ideal case that we want, that the coefficient which has positive sign, the sum of all that, and the coefficient which has the negative sign, the negative of that. If you do it, you will get the target value. And then if you add to, that is the coefficient which results in the positive value and S which results in the negative value. So this would be the total sum, basically the sum of all the coefficients. So if we solve this equation, we will get 2p to be the target plus total sum. So p would be target plus total sum by 2, and S would be the negative of this, that is target minus total sum by 2. So what here we are actually doing is, instead of finding the all the possible combination, we will try to find the S. So S basically represents a small subset which results in the sum of coefficient which has a negative sign, and the length of the S would be the target value minus the total sum value divided by 2. Oh, sorry, this should be in the opposite. Total sum minus target by 2. So we want to take the S, which will be the sum of the coefficient which has a negative sign, such that the total sum minus target divided by 2, that would be the sum of the coefficient values. So the total sum, that is the sum of the coefficients. If target is greater than the total sum value, then in that case also it is not achievable, or the total sum minus target divided by 2 is not equal to 0, because sum of all the integers here. So S will also be some integer case, but if it not result in a some decimal value here, then in that case also it will not be possible. So it returns 0 with the value of S, the total sum minus target, and the integer division of that. Then we are creating a DP array of zeros for the length S plus 1, and initializing the first one with value 1. So what does this DP represent is the number of ways for which the sum of the coefficient would be 0. So that can be for the 0 sum. If you want, we can basically take nothing in the set. So there's only one possible way in which we can take the sum of all the elements to be 0. Then we will move with, for num in the coefficients. For each coefficient value, we are going from backward for num minus 1 till S. And what we are trying to do here is, if we have the way in which we can achieve the sum of j minus num, then we can add num to that and get the sum of j. So in that way, we are filling this DP array, and in the end, we are returning the possible combination of the sum S. Then the latter part is pretty much same, that we are taking the input of t Then we are looping through the number of test cases. We are taking the target, the length of the array, creating the coefficient array, and then we are passing this coefficient and the target into find target sum ways function that we defined here, and getting the number of ways and printing it. The solution is pretty much same for others also, just we are using long to avoid overflow, and for C also we are using a long, and same for the Java. Just we have to take care of this long here. So any doubt here?
All right, let's move on to the 12th and the final week, which is also on BP. So let's see the first question, week 12, problem 1. Okay. So in this question, you are basically a microbiologist and are given n genetic strings, and these genes might belong to different people. However, there's a high likelihood that there has been at least 2 genes that are of the same people. However, as the sample might have been taken from different part of the body, even if the genes are of the same person, they might not be exactly the same. So you have to find out basically if they are similar enough. So given this, you have to find the most profitable 2 genes which came from the same person. So the probability of 2 genes Si and Sj being from the same person, which is denoted as P of Si Sj, is given by the following formula. So P of Si Sj is 1 minus e to the Levenstein of Si Sj divided by the sum of all the pairs of I and j. So this is basically all the unordered pair. So we are going from I to 1 to n, but then the j starts from I plus 1 to n. It doesn't go again from 1 to n. So we take only one combination of each I comma j. So we don't consider I comma j and j comma I as separate entities, because the Levenstein distance is a symmetric distance function. So we take all the combinations and we take the e to the Levenstein of them, and we take, sum all of them. Right? So obviously e to the power something is a positive number. So some like division of a positive number by sum of all those positive numbers is just a positive number between 0 and 1. And we just negate that by doing 1 minus. So we just get another positive number between 0 and 1. So this is the probability. And so Levenstein is just a distance function between 2 strings. So if you are not sure what that is, you can look it up. But it's basically is similar to Hamming distance, but instead of just considering the substitutions, the Levenstein basically consider 3 different changes. One is the addition. The second is deletion. So basically both sides addition to A and addition to B. And finally, substitution. So you substitute one letter with another letter in the strings. So this is how the Levenstein distance function works. And for each of these actions, you add +1, right? So if you have to add one, so you add +1. For deletion, you add +1, and for substitution, you have +1. So these are equiveighted. So a Levenstein function is also a symmetric function, as we saw. And this can also be written more succinctly as the softmax, right? So 1 minus the softmax of the Levenstein of Si and Sj for all the strings, which is the set S, where S is the set of all the possible unordered pairs of the genes. So here is a very brief example, explanation of what the Levenstein function actually is. So the Levenstein distance between 2 strings is the minimum number of single character edits, insertions, deletions, and substitutions required to change one string into the other. So for example, the Levenstein distance between intention and execution is 5, because we can turn intention into execution in 5 edits. So what is an edit? Edit can be insertion, deletion, or substitution. So first, if we remove the p, so intention becomes inention. Then we replace I with an e, so this becomes this. Finally, we do, so not finally, the third step, we replace n with x and we get this. Then we replace n with c and we get this. And then we insert u and we get the final answer. I think it's not written here. That's a mistake, but we basically get execution as the final answer after doing this execution, the final insertion. So in 5 edits, we can get execution from intention. We have to basically find the pair of genes. So there are 2 strings, Si and Sj, which has the highest probability P, Si, Sj. Right. So there's a catch obviously in this, which is there's a catch in this in which so you don't actually have to calculate the uh, Levenstein function and the you have to find the Levenstein function, but you don't have to calculate the softmax of all of them and do a subtraction. So we'll also go through the proof in the end. But basically, you can just find the distance between all the pairs of the strings, and the pair that has the minimum distance is the one that will have the maximum probability. So it might be obvious to some of you just by seeing this, but for others, we'll also go through the proof of that. So the input again is very simple. So the first line is the number of test cases. And then for each test case, we have one integer, which is the number of strings. After the second line of each test case contains n space separated integers, so it's basically given as mi, that I belongs to 1 to n, and is of the length, which is of the length of the ith genetic string. So first you get the number of strings, and then you get length of each of these strings. And then finally you get n lines, which are the strings. And each of those lines contain the ith string. So the ith line contains the ith string, which is of length mi. So the length that was given earlier. So more succinctly, Si is simply a Cartesian product of the set A, C, G, and T to the power of mi, which is the length of the string. So this basically means that the string can only contain A, C, G, or T as letters. Those are the 4 nucleotides that we have in the DNA. If it's RNA, then instead of one of these, it will be U, uracil. But other than that, basically this is for the DNA. And the length is mi. So then we have the constraints that is given to us. So the T, N, and M, all of those will not be greater than 100. And as we saw, the string will always contain only these 4 letters. And this constraint, you have to think about it a little bit. But what this basically means is log base 10 of t plus 2 times log base 10 of n plus 2 times log base 10 of n is less than equal to 7. So if you just remove the log, you get t plus n square plus m square is less than 10 to the 7. So, sorry, t times n square times m square is less than equals to 10 to the 7. So this is basically the time complexity of your code, like the expected code. And it is given that that will never exceed 10 to the 7, so it can be executed in 1 second. So basically a time complexity of O of t times n square times m square is acceptable for this question. And finally, the Levenstein distance of 2 strings is always greater than or equal to 0. It's 0 if the strings are identical. And we also clarified that Levenstein is a symmetric function. So Levenstein of a comma b is same as Levenstein of b comma a. That is, it is a symmetric function. So for the output, you simply find the most probable 2 genes which belong to the same person and print their Levenstein distance. So here again, you can see that even if 2 or multiple pairs have the same Levenstein distance, you don't have the confusion of which one to print. You just print the value instead, which is the Levenstein distance. So here again, you can see that you just have to calculate this because this is explicitly asked, but we don't have to do the softmax. So we will see why after this. So here this is the example input. So we have one test case where we have 2 strings, each of length 3. So the first is ACC and second is AGC. So here the Levenstein distance, so AA is same, so we don't change. CC is changed, so we don't same. It's same, so we don't change. And C and G are different, so we can just substitute one to the other. And in one edit distance, we can get the one string to be the other. So now because here we only have 2 strings, so there is only one pairing possible, which is SCC with AGC. So that itself is the most probable one. And we print its distance, which is 1. However, if there are multiple, we have to basically do it for all of them and find the one that has the lowest distance. So let's see the solution. I think the explanation might not be here. One second. Okay, so let's see the solution first. Okay. So first we have to define the function to find the Lernstone distance itself. So it's taking two strings, word1 and word2, and we're just finding their lengths, m and n are the lengths, and we create a DP table. So this is a two-dimensional DP problem. So we create a two-dimensional DP table for the words. So it is of the size n cross m for both the strings. And then we just fill up the table. So for I in range, we just set all the I comma 0 to be I and all the 0 comma j to be j. So this is filling up the first row and the first column. And this is important because once we have the first row and the first column, we can just keep on filling the table in a like top to bottom fashion and left to right fashion. So each cell just depends on the cell on top and cell on the left of it. So if we initialize the first row and first column, we can keep on filling each row. So we can either fill it row by row, or we can also fill it column by column. That's totally up to us. So we simply then iterate over the array, right? So it's a very simple now. Once we have computed the algorithm for this bottom-up DP, so we just iterate over each row and each cell in that row. And if word one of I minus one is same as word two of j minus one, then the DP remains the same. So DP of ij is same as DP of I minus one, j minus one. So if the letters are the same, then we don't have to make any changes. So the DP at that I comma j is same as the previous one. So we don't make any changes. We just move on to the next letters. However, if there is a difference, we have to actually find out which action is best of the three edits. So we can either add, we can subtract, or we can substitute. So we basically, those are encoded in the three directions that we have. So that is dp of I minus 1, j minus 1, dp of I minus 1, j, and dp of I, j minus 1. So the top, the left, and the top left. So whichever that we have, so I minus 1, j minus 1, uh, I minus 1j or I j minus 1, whichever we have, we take that and we add plus 1. So this is because we are now performing one action. Whichever action we choose, all have the same weight. So we simply take the minimum that is already there, and then we add plus 1 to get the new count at this. If we did not have the same weights, then we have to basically add the weights in the parameters itself. So it would be this plus the first weight, comma this plus the second weight, comma this plus the third weight. However, because all of them are one, we can just take the ones as common and take it outside. And finally, we return the DP table of m comma n. So the last value that we have is basically once we have replaced the entire string with the like word one to be word two. So this breaks down the problem into like sub problems all the way till the size of one, and then for one letters we know how to do the substitution, and then we build back again and find the solution to the entire question. And the driver code is pretty simple. So we take the test cases, we iterate over the test cases, we take the number of genes, we take the length of each of those genes, and then we take so the length is not required in Python, but it's required in C, mostly in C, but also in other languages, depending on your code. And then we store these strings. So each string is then stored in a list. So finally, we take the minimum distance between two pairs that we have in these strings. So we initialize the minimum distance to be infinity. And then we iterate over all the pairs. So we iterate over all the unordered pairs. So we are going I to full range and j just from I to n, and not again in full range. And then finally, for all the pairs, we just find what is the minimum distance of that pair. And if that is smaller than the current minimum, we update the current minimum. So that is how you find the minimum distance. And the minimum distance of all the pairs is our answer. So we just simply print the minimum distance over all the pairs. Now let us also quickly see how finding this itself is enough. Right, so just give me 1 second. All right, so let me share my screen. Okay, yeah, sorry for the delay. So this is basically a very concise explanation of this. So let me also walk you through this. So what this means is if you want to find the uh, argmax, right? So if you want to find the argmax of this, so you basically, this is what is given to us. So you find the softmax of this 11 10 distance between two pairs of string for all the strings, and you take the 1 minus softmax, and you want to find which two strings or which pair of string A and B will give you this minimum value of this. Sorry, the maximum value, because this is the probability, and we want to maximize the probability. So maximizing the probability is same as minimizing the length itself or the value itself. So this is true because this, which is the softmax function, this depends only on the like the numerator. So as you can see, the denominator is always same for all of the values. So whatever is A and B, the inside equation, the denominator does not depend on A and B at all. Only the numerator depends on A and B. So if we just compare this equation, so if you want to, let's say, minimize this, which is same as maximizing the negative of this. So we have a negative here, right? So if you want to minimize this, the minimization or the argmin, to be precise, the argmin of a thing A by B is over A is same as the argmin of A, because the B is just a scaling and it doesn't depend on the variable that we are optimizing over. So because the denominator does not contain A or B, we can just ignore this and we can say we just want to minimize this because we are maximizing 1 minus this. So we are basically minimizing this. And minimizing e to the x, as we saw in week 10 again, is, so argmin is same as the argmin of x itself. And this is again because e to the x is a monotonically increasing function. So if a function is monotonically increasing function, which basically means that it does not decrease, it always keeps on increasing. So getting a higher value of the function is same as getting a higher input to the function itself. So this then means we can just minimize the Levenstein of a comma b to maximize this entire thing. So that is basically what we have written here. So minimizing the pairwise distance between two strings is the same as maximizing the probability that they belong to the same person. Right? So this is how we can solve this without calculating the softmax. And so we'll stop the uh, session for this question. So we'll move on to the week 12 problem 2.
Okay, so let's start with week 12 programming assignment question 2. So in the initial part, we have given what happens in the machine learning case if you increase the complexity of a model, and something about overfitting. And one way to overcome the overfitting case is feature selection. So when you have too many features, then it increases the complexity of the model, which might result in overfitting. So that is the case. Basically, your model is performing very well on the training data set. That is the data set that is already available to you. But on the test data set, that is the unseen data set, okay, on that part, it is performing very poorly. So that is, instead of learning the pattern, it is memorizing it. So that is what it does mean by overfitting case. And one way to achieve the or overcome this issue is feature selection. Instead of taking all the features into account, we take a subset of features. So Namdusan, a math genius and the founder of Samsung Tech, is developing a machine learning model, and he has a data set with D features and an array named scores, where the scores I represents the predictive power score of the ith feature if you select this ith feature. And through some analysis, he observed that selecting a feature with score, let's say Si, introduce a correlation with the features having score Si plus 1 or Si minus 1. So if the Si value is 4, then if you select this feature which has a score of 4, then it will introduce a correlation with any other features which have a score of 5 or 3. And more formally, we can write it as if S is the set of all the available feature to us, then if a feature with score Si, which belongs to this set, if you select the feature, then all the feature with the score in the correlation neighborhood is defined as Si minus 1 and Si plus 1, the intersection of these two. So this will select the features which has a score of Si minus 1 or Si plus 1. So we have to exclude these features in the selection process. So given this feature selection constraint, our goal is to determine an optimal subset of all the features which we are representing as S star, which will be a subset of this, such that the total predictive power that is given as the sum of all the scores from the S star, the selected feature set, is maximized, while ensuring that for every selected feature S, neither S minus 1 or S plus 1 should appear in the set S star. So this was the problem statement. Now the input format is the first line contains the integer t, which represents the number of test cases given to us. And for each test case, there are two lines. First one, a line contains the integer d, which is representing the number of features over the length of the array scores. The second line contains d positive integer, where each integer represents the score of the feature. And these are the constant, and the output is a single integer represent the maximum total predictive power that can be achieved by selecting the optimal set of features. So let's look at the test case. For this one, the array is 3, 4, 2. So let's say if you select this feature which has a score of 3, then because we have selected this feature, then the 3 minus 1, 2, or 3 plus 1 equal to 4. If the 2 and 4 are available in this set, if there is any feature which has a score of 2 or which has a score of 4, then we have to exclude those feature if you select the feature having the score 3. So those two are available. That means if you select the feature 3, then you have to extract these two features. So the only optimal goal that we can achieve here is 3. While if you select the feature 4, if you select the feature having the score of 4, 4 minus 1, 3, and 4 plus. So 3 is available here. So if you select the feature having the score 4, then you have to exclude this one. So in that case, but the 2 will not be excluded here. So the total predictive power in that case would be 4 plus, because we can select the 2. And in that case also 2 will also eliminate the 3. If you select 2, then 2 will also eliminate 3, because 1 is not available. So these are the two features which we can select having the score of 4 and 2, which will eliminate 3, but the total predictive power in that case would be maximized to this. For the next case, if we see for 2, 2, 3, 3, and 4, now if we select the feature having the score 2, then this will eliminate any feature having the score of 1 or any feature having the score of 3. So that means it must be 1 more 3. So that means these 3 will be eliminated. So we can add these two although. So this will give us 4, and we can select the 4 because 4 also will eliminate the same 3's here. So in that case, the sum that we will get would be 8. But if you select all the 3's here, then the 3 will eliminate 3 minus 1, 2, and 3 plus 1, 4. But in that case, if you check the total predictive power, that would be 3 plus 3 plus 3, 9, because there are 3 3s. So that would be maximum here. So in this test case, we will select all the 3s and eliminate the 2 and 4. So now let's look at the solution part. So we are defining this function maximize spread power, which takes the input of the scores array. Then we are checking the frequency of each score appearing in this. So for that, we are creating this array with 0 times max of scores plus 1. So then we are filling this frequency array. For n in score, we are incrementing it with n. Then we are creating this TP array of the length frequency. And for the first one, we are creating with what is the frequency of 1 appearing here. Then we are looping through the length of the frequency. And what is happening here is basically whether if you select the features with the I, then the and in the end you are creating the last array, extracting the last element from that. That is the maximum predictive power. The rest part is same for all that code, that you are taking the t as the number of test cases input, then you are looping through that, and then taking the d, which represents the total number of features, and creating the score list and passing that score list to this function and printing the max score. For the C and C++, we have to initialize this as per the constraint. So the constraint given to us that the highest it can go is with 10 power 5. So we are initializing with that one more bigger number to that. And the rest of the part is same for the C also. And Java also we are initializing with max score. Yeah. So any doubt? Okay.
Okay, thanks, Pulkit. Thanks, Jan. Jia has asked, can you please tell me important topics for exam? Yeah, so for exam, actually, you will get the similar type of questions of your practice quiz and graded quiz. So that are the one thing, one part. Another part in the exam will be like a comprehensive type of question. So maybe some problems statement will be given to you, and based on that, some questions will be asked in some partition way. So you can practice on that type of question. That means you should know how to solve any problem. Okay, how to figure out the logic of any problem. So also understand all the problems which are discussed in the lectures, and also understand the way how that problems are solving. One sec. Huh. So in this way, you can revise the all problems, so that programming questions are also important. So how you can solve these programming problems, how you are getting the logic, how you are reaching to the output. So in that way, the paper will be come. So some programming question like questions type will be the same like quiz, assignment, MCQ, MSQ, or numerical input type of questions, but the questions will be type of like comprehensive. Okay, so maybe some problem, and based on that, some like logic okay, idea of that question. And some part of the questions will be of your similar type of your assignments quiz. So you can just recap all the things. Any other query, anyone? And weightage, regarding some query we have received regarding the weightage for this 25% is marks. So that will be taken like as a average of best 8 out of 12 quiz, total 12 quiz in the week, 12 weeks. And that will be considered as for the 12.5 marks. So for the programming assignment, we will consider 12.5 marks for best 14 problems score out of total 22 problems. In this way, this 25 marks score will be calculated. Okay, and remaining 75 will be calculated through the proctored exam. Any other specific queries anyone have?
So paper is a 1 hour.
No, duration will be, I think that will be given to you in the document, no, in the exam. I think duration is 3 hour, I think. But I'm not sure, just wait for the hall ticket. I think hall ticket is released now.
Yes, sir. So there 1 to 2 is written.
1 hour duration is written.
Yes, sir.
Not sure about this. You can just write to the discourse, okay, like a forum. Okay, so you can write just one post on the forum on the course. Then the support team will be replied. I'll check with.
Okay, sir.
Okay. Okay.
So means for revision, we'll just basically do assignments and the quiz, as only 1 week is left.
So for revision, all the assignments, practice quiz, graded quiz, also the programming assignments. Okay, so that is also helpful. Okay, and that course content is also important. So I'm not sure how. When is the exam?
So 27 on Sunday.
Okay, so you have a still 10 days approx. Yeah, so you can if you can do you can also recap the problems, how the ma'am actually explained the problems, the video content.
Okay, sir. Thank you, sir.
Okay. There's no code writing based questions, so the questions will be only like MCQ, multiple select, or numerical input. There's no code writing based question.
Okay, sir. So means there is only MCQ's question.
Not MCQ, like multiple choice, there where the one answer is correct, maybe multiple answer will be correct. That is called as a MSQ. And numerical input, if some numerical value you need to put. Okay.
Okay, sir. Integer
So
based answer.
similar to your that quiz assignments.
Okay, sir. No coding will be there that we have to
Hmm.
include. Okay.
No coding writing based.
Okay, sir.
Okay. Any other query? Okay, so if you have any query, you can also write to the forum. Okay, so we will try to resolve. Okay, then thanks everyone. Bye. All the best for the exam.